Okay, so let's continue with the systems unit. We're going to be looking at the application problems. That's numbers 45 and 46. Okay, so what you do first is just a really quick read of it. The perimeter of a rectangle is 28, length is 10 centimeters longer than the width. Find the length and width. All right, and as you're reading it, you kind of think about, okay, well, let's see, perimeter, that's of a rectangle. Here's a rectangle. The perimeter is twice the length plus twice the width. That formula was actually earlier in the exam. Okay, so it's like if this is the length and that's the width, the perimeter getting all the way around it would be 2 W's and 2 L's, is what we're saying. So if the perimeter of the rectangle is 28, we know that 2L plus 2W has to equal 28. And if the length is, that's the length is 10 centimeters longer than the width is W, 10 centimeters longer than that would be W plus 10. Then you've got two equations here. So what we did is we let length be L, width be W. We set up two equations because you got to use a system. That's the whole point of this section. So then you take your two equations and you solve it. And on this one, since L is by itself, it's a good elimination type, substitution type. So I'm going to put the W plus 10 in for the L. So right there where the L was, I'm going to put W plus 10. Okay, so now I have an equation. This is after I've substituted. I have an equation that just has W's. So I'm ready to distribute, combine like terms, and then I have an equation I can solve. I'm going to take away the 20. And then divide by the 4. And I wind up with W being 2. Okay? And then once you find one of the variables, you can go back. I'm going to go back over here now. I know the length then would be 2 plus 10, or 12. And then I'm going to check it against the words of the problem. So think about that rectangle. If the width is 2 and the length is 12, so if that's 12, then this is 12. If that's 2, then that's 2. And the perimeter would be all the way around, which would be 24 plus 4, which would give me the 28 I'm supposed to have. So that's kind of my check. All right, now look at 46. 46 was the one where you had the adult and the children's tickets, money collected and all of that. So you have the first thing that I really use is how many adults and how many children attended. That's where I decide what I'm going to let my variables be. So X might be adults, Y might be children. So if there are 590 people at the play, I know those two have to add up to be 590. Okay. Now, each adult ticket costs $3. So if I do 3X, that's how much money the adult tickets brought in. If I do 1Y, that's how much money the children's tickets brought in. And then all total, there was $1,230. So those were, when we did them in class, we used this scenario where we organized the data. We had number of tickets, we had the cost per ticket, but you've now seen this problem several times, so you might be able to jump right to the system.
Hey, Mom, I'm doing okay. Yeah.
Okay, oops, I wasn't talking. I should have been. Okay, let me go back. So back when we did this before, we set up a table like this. We had number of tickets, cost per ticket, And we knew if we multiplied those, it would equal the cost. So we could put the number of adult tickets, the number of children's tickets, the cost for an adult ticket, the cost for a child's ticket, the total cost for adults, the total cost for the children, or the total, not cost as much as money collected might be better. The money collected for the adults, the money collected for the children. So you wind up getting one equation from there and the other equation from there. So adding up the types of tickets gives you 590. Adding up the amounts of money collected gives you 1230. Okay. All right, now let me go back. So now we have our system. We have our two equations. We can solve that by multiplying through by a -1 on that top one, and then the y's would be opposites and they'd cancel out when we add. So -x, +3x would be 2x, -y, +y would be 0, -590 and +1230, if we subtract that, we'd get, what would that be? 640? 640, yeah. So then I can just divide by 2, and I'd know that x would equal 320. Now 320 is x, and I have to go back here to see that x was adults. So 300 adult tickets were sold, or 320 adults attended. Okay. And then I know from earlier that altogether, remember altogether 590 people came. So if I had 320 adults, I could find the number of children, couldn't I, by just subtracting it from both sides? Okay, when I do that, I get that y equals 270. So 270 children attended. Okay. All right, so that's the two word problems. Let me go ahead on here and post this, and then I'll do the inequality.